So now that you've been introduced to matrices, let's see how we can operate with these new entities. For example, addition. How can we add matrices? Say we have one matrix and another matrix. Is there a meaningful way that we can add the two? And what should the result be? Well, it turns out that the most meaningful way of defining matrix addition is just by adding each element of the two matrices like this, so that the result becomes 5, 2, 7, and 9. Please notice that this definition of addition makes it impossible to add matrices of different dimensions. This is because these two matrices, they live in different spaces, so you can't add them. In the same way, you can't add a three-dimensional vector to a two-dimensional vector, or to a scalar for some reason. You can't. There's no meaningful way of adding these. It's like adding like a volume, say the volume of this cube here, add that to an area of this sheet. There's just no meaningful way of defining such an addition here. So that's just no go. By the way, this is a 2 by 2 matrix. This is a 3 by 2 matrix. And for obvious reasons, we call this a square matrix. This is not a square matrix. So let's just remove all these impossible operations here. Like that. And I haven't said anything about subtraction yet, but subtraction is kind of the same procedure as addition. So if I add a minus sign here, I should just replace the plus sign by a minus sign here. And of course, the results would be different over here. But the idea is the same. In order to appreciate why we have chosen this definition of addition and subtraction of matrices, you should bear in mind that these matrices, they could represent systems of linear equations like we've seen earlier. And if that's the case, then we might interpret this matrix as this system which might equal some other variables, and likewise this could be another set of equations that would equal a third pair of variables. Now, this gives me two equations, and if I add the right hand side of this equation to the right hand side of this equation, I should be able to add the left hand side and the left hand side of the equations as well, and still obtain something that's valid. Let's try to do that. So I add the left hand sides and the right hand sides of the first equation, and I obtain 2x1 minus 3x2 plus 3x1 plus 5x2 equal y1 plus z1. And if I collect the x1s and the x2s, I get 2 plus 3 x1 and minus 3 plus 5 x2 equals y1 plus z1. And of course, that brings me to this equation, which in terms of matrices could be written as 5 and 2 equals y1 plus z1, and that would be kind of like the first row of the sum of these matrices, and of course we have the same coefficients as in this matrix. So this hopefully justifies our definition of matrix addition and subtraction. It's all a matter of making sense and putting meaning into this interpretation of matrices as systems of linear equations.